Hello and welcome to our lesson for today on 4.8 Operations with Complex Numbers. If you have not already done so, please take a moment to press pause and complete the warm-up. So I wrote down the special pattern that I would use in order to multiply out the conjugate here. So the conjugate for multiplying is 4 plus radical 5, 4 plus radical 5. Using this special pattern, which is the difference of two squares, I would square the first term, which was 4, and then subtract the square of the second term. You could also FOIL this all the way out and you'll get the same thing, which is 11. Multiplying the top, I have 12 plus 3 radical 5. And then for number 2, after I solved, I got plus and minus radical 5. For number 3, x equals negative 7 plus or minus radical 2. If you need to, take a moment, press pause and check to make sure that your work matches mine. You can also check in with a neighbor and see that you have that written down okay. So here's our first portion, 4.8 Operations with Complex Numbers. The imaginary unit I is what we're dealing with today. The definition of I is that I is equal to the square root of negative 1. I is equal to the square root of negative 1. And so imagine if we have this, and if I were to square both sides, then I have I squared is equal to, well, so what happens here? The square and the square root cancel out, so it equals negative 1. That's what's happening in this part. So there's two things I want you to remember for today. Number 1, I is equal to the square root of negative 1. And then number 2, I squared is equal to negative 1. Two important facts. There's probably going to be one more a little bit later on, but I'll talk to you about that then. This is a little bit more definition stuff, but the main takeaway here is if I had the square root of negative 25, this is like saying the square root of negative 1 times the square root of 25. Well, the square root of negative 1 is I. The square root of 25 is 5. So this would be 5i. Similarly, the square root of negative 4i, of just negative 4 is 2i. Square root of negative 9, 3i. Square root of negative 16, 4i. So in order for me to deal with these negatives, I'm just going to pull out an I. So complex numbers, if you could please do us a favor, and let's read this just a little bit together. First of all, complex numbers are in standard form, or written in standard form is written as a plus bi, where a is the real part and b is the imaginary portion. So if I had something, for example, 3 plus 2i, the real part of this is the 3, because that's a real number, and then the imaginary part is anything that has an I attached to it at the end. So if you could place each of these numbers in each of these areas as best you can, and I'll talk you through that. This 3 plus 2i would go in the real 3 plus 2i. This negative 5i, so I'm just kidding. Psych. This is a plus 0i. 0i means that there is 0 imaginary portion of it. So none of it is, 0 of it is imaginary. So 3 plus 2i would be in my strictly imaginary portion. And then this negative 5i, there's a pure imaginary. And what makes this a pure imaginary number is that there's absolutely nothing real about it. Some of us know some people like that. Sadly, this 10 is a real number. We've seen it before. So I'm going to put that 10 in there. And then I squared, where would I put that? Real, imaginary, or pure imaginary? Well, if you remember from a minute ago, I squared is equal to negative 1. So I squared is a real number because it equals negative 1. It's a little bit of placement. Now, this confuses a lot of people, and they tend to hate it. So I'm not going to torture you with that. I'm going to tell you, first of all, make this correction so that that's a closed parentheses. And in order to do these, here is your key to success. Combine like terms the same way that you would with any other lesson. So you're going to add the real with the real and the imaginary with the imaginary. I have negative 1, that's real, plus 3 is 2, and then I have 2i plus 3i, that's 5i. That's it. Just combine like terms. Main thing here is making sure that you put it real and then the imaginary. This is standard form. Take a moment if you would please and press pause and then try number 2 on your own. Okay, so I just distributed that negative right here and here. So I have 2i minus 3 minus I plus 2 minus 3i. Combining like terms, I started with the real ones first. Negative 3 plus 2 is negative 1. 2i minus 1i is 1. Minus 3i is negative 2i for that one. Very good. Okay, if you can flip your page over, we're going to talk about multiplying complex numbers. Not complicated, it's kind of what you've done before. So think about it. In your past, you would have distributed first. So I times 3 is 3i. I times I is positive I squared. In the past, you'd be done because you couldn't do anything else. But this is 3i, nothing I can do with that. But I squared, remember, is negative 1. So I'm looking at 3i, what's a positive times a negative? Negative 1. Do I have a problem with this? I do. I would lose 1 full point for this problem right here. And the reason why is because it does need to be in standard form. So negative 1 plus 3i. A plus bi is always going to be standard form. You always want to end with the imaginary. All right, so number 4, and if you would like to, you're more than welcome to just go ahead and take a moment to FOIL or distribute or however you multiply this out. So 2 times negative 6 is negative 12. 2 times negative 2i is negative 4i. On the inner part, I have negative 6 times 3i, so it's negative 18i. And then 3i times negative 2i, that should be negative 6i squared. Negative 6i squared. Okay, so I have like terms right here, these two imaginary parts. So I have that negative 12, and then negative 4i minus 18i is negative 22i. Minus 6, and now this I squared. Well, we know already I squared is equal to negative 1. It was one of the main things I asked you to remember. So now I have negative 12 minus 22i. Negative times a negative makes this plus 6. And then combining these two terms, because I have two real parts, I have negative 6 minus 22i. There you have it. So on your warm-up, we first had to multiply by conjugates. Well, now I'm going to tell you, these are conjugates of each other. A plus bi is a conjugate of a minus bi. What makes them conjugates is that when I multiply them out, do this with me. This is the other thing I want you to know for the day. I should not have any more imaginary parts. Just like when I multiply conjugates for radical numbers, when I multiply them out, there's no more radical. So multiplying out, I have a times a, which is a squared, and then a times negative bi, negative abi. Inside, I have bi times a. I'll just write them in the same order, plus a bi. And then what's bi times bi? Well, b times b, oh, this is minus. B times b is b squared. I times I is I squared. Okay, and again, that's minus. So in the middle, this wonderfully cancels out. So I have a squared minus b squared times I squared. Well, what's I squared? I squared is negative 1. So this is going to be a squared. Well, what's a negative times a negative? Plus b squared. This is a new special pattern that we can use every single time. But what happens if you forget it? No one cares. You just FOIL it out the same way that we just did here. So my directions here are to multiply each thing by its conjugate. So the conjugate here would be 6 minus 3i. And if this is conjugates, if it's real, then it should follow this pattern. So this is like a plus bi times a minus bi. And so this should be a squared minus b squared. Special pattern alert. So what's the a in this case? 6 squared. Plus b squared. Well, what's the b? The number in front of the I? 3 squared. That's how it works out. 6 squared is 36. 3 squared is 9. So my answer is 45. This looks a little bit different, but it's not really. I'll just tell you. The conjugate of 4i is, wait for it, negative 4i. It's because 4i is 0 plus 4i. So the conjugate would be 0 minus 4i. But what's 0 doing to it? Nothing. Because what's 0 plus 4i? 4i. 0 minus 4i minus 4i. So 4 times negative 4 is negative 16. I times I is I squared. So negative 16 times negative 1, which would be positive 16. Noticing here, I squared is doing one thing and one thing only. It's basically just changing the sign. Okay, last one for you. Dividing complex numbers. So the same way that we cannot have a radical in the denominator, we can't have an I in the denominator. Because remember, I is basically the square root of negative 1. So I'm going to multiply by its conjugate, which is negative 5i, and then distribute. So up top, I have negative 10i plus 15i squared. In the denominator, I have negative 25i squared. Simplifying, I have negative 10i, and then what's I squared? Negative 1. So 15 times negative 1, negative 15. Remember, I squared changes the sign. So what does it do here? It makes this positive 25. It's like saying negative 25 times negative 1. So I'm going to write these as separate fractions. And then 15 over 25. Two things need to happen. One, I do need to reduce. So I'm going to divide by 5. This would be 3. This would be 5. I'm going to write this negative 3 over 5 first because it's the real portion. And I'm going to divide by 5 and divide by 5. So this would be negative 2 over 5i. Just tack the I there at the end. Don't put negative 2i over 5. Bueno. Okay, let's multiply by that conjugate. So 1 plus I, and then 1 plus I. If you feel pretty good about this, do me a favor and go ahead and press pause. I'm just going to go ahead and multiply this out. 2 times 1 is 2. 2 times I is 2i. 7 times 1, negative 7i. Negative 7i times times positive I, negative 7i squared. And then I'm going to pause because the conjugate is actually subtracting here. That should be minus. My bad, because these have to have opposite signs. So this will be negative 7 times 1. What else changes here? This is 2 times that, so this is minus 2i. My apologies. Negative 7i times that will make this minus 7i, and then this will be plus 7i squared. Bet you wish you paused and did it by yourself now. And then for this one, this is 1 plus 1i and 1 minus 1i, so the a is 1 squared minus the b is also 1 squared. Combining my like terms, I have 2, these are alike, minus 9i plus 7 times negative 1 over 1 plus 1. Ooh, this is plus. 1 squared plus 1 squared would be 2. So this is 2 minus 7i. Just kidding. Minus 9i. I was thinking ahead about this minus 7. Over 2. So simplified, this is negative 5 minus 9i over 2. And then as separate fractions, that's negative 5 over 2 minus 9 over 2i. Okay. Last one. Let's solve this as you normally would. So go ahead, take a moment and solve as much as you normally would. So typically we would stop here and say, oh, no solution. But now that we know how to deal with the i's, we know we're going to have positive and negative. Perfect square is 9 times 2, and then there's still a negative 1 in there as well. So what can I take out? Well, there's a 3, because the square root of 9 is 3. And then this negative 1 in here means I can also take out an I. And then what's left is just the 2, because this came out and this came out. The only thing left is to write this in standard form. So positive and negative, 3 radical 2 I. Just make sure that this radical stops right after that number and does not include the I. All right, thank you very much, and I'm sure you have an exit ticket to do.